Alright, let's draw it first. So they're both relatively easy to draw. This one here, if you factor out 2x, you get 3 minus x. So this is a parabola that's going upwards, a simple standard parabola. Okay, this one here has a root at 0 and a 3. 1, 2, let's say 3. So it's going to look like this. So the boundary area we're talking about is this one. And we're going to rotate about the y-axis. Okay, so it's going to look something like that, right? Okay, we're going to do this by cylindrical shell. So let me draw, and you have to be able to do this too. You got to be able to draw a typical cylinder. So I'm going to pick an x value. There's my x. Then that's going to be my height of the cylinder. So there's one on the opposite end too. Right here, like this. And there's my cylinder, okay? Now, cylinder is defined by two things. First, the radius. Second, this height. Right? They both need to be defined in terms of x. Okay, here's my x of the function, okay? Here's my x. Do you see that the radius is x? Radius of cylinder is equivalent to that x coordinate. What about the height? Height is the y coordinate of that function, the parabola on top, subtract by the y coordinate of the parabola on the bottom. True? Yes? Okay, so the one on the top is this one, right? So I can write this. 6x minus 2x squared minus the one at the bottom is this one. So I can just subtract x squared, so you get 6x minus 3x squared. So that's all we need. After this, look, we know the cylindrical shell method requires this. 2 pi r as a function of x, height as a function of x, dx. And we're integrating from where the x starts, which is 0, and finishes, which is where they intersect, which is 1. Okay. You know what? Actually, I don't know that it's intersecting at 1. It does? You gotta make these two equal to each other, right? I think it's gonna intersect at 2. Let me see here. If you make those equal to each other, 6x minus 2x squared is equal to x squared. 6x minus 3x squared equals 0, so 3x, you get 2 minus x, right? So it intersects at 2, so we have to integrate from 0. That right there is 2. Okay, so 0 to 2. Alright, so 2 pi, we have the radius, which is x, the h is 6x minus 3x squared. Okay, now it's just typical antiderivative question. Okay, so it's going to be 6 divided by x cubed, 2 times x cubed. It's going to be 3 over 4 x to the power of 4. Continuing here, 2 times 8 minus 3 over 4, 16. 4. 8 pi is the answer.
How did you get that the radius equals x?
How did I get the radius is equal to x? Okay, look. So this is a typical cylinder. You agree here. You agree that this is the radius of the cylinder, right? Okay, so I want to know what that radius is in terms of the x and y of the functions that are given. Okay. So here. Do you see how, right, there's x points, there's on the curve there's x and y points, right? So here, let's say there's like an A and a B, okay? But that A represents this length, right?
Yeah.
But that is this length. If I pick a different value, x right here, if I draw a cylinder there, let me draw a different cylinder. let's say I draw, here's my new, let's say C, okay? Let me draw a cylinder there, like this. That's my radius now, right? Do you see that that's equivalent to this length C? So it's always equivalent to the x value on the function.
So it's always x.
Yes, in this case, because we're particularly rotating about the y-axis. If you're rotating actually like here, that's not the case. It gets a little bit more complicated.